Hello. In this lesson, we will discuss about quantifier over finite domain and quantifier over restricted domain. Let's get started. Quantifier over finite domain. When the domain of a quantifier is finite, that is, when all its elements can be listed, quantified statements can be expressed using propositional logic. It will be cleared in the next line. The universal quantification, the sign of universal quantification, x, p of x is same as the conjunction if you know your limit when it is finite. P of x1 and p of x2 and dot 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 and p of xn. That means if you have some function and know for which values the function will be valid, and then you do this type of propositional logic, make a statement, and then you find out your universal quantification is true or not. Alright. As for existential quantification, it will be disjunction. Alright. So if one value is true, then this existential quantification will be true. Let's do example. What is the truth value of universal x, p of x, where p of x is a statement x square is less than 10 and the domain consists of all positive integers not exceeding 4. That means your values should be 1, 2, 3 and 4. So p of 1, 2, 3 and 4. This is equivalent to 1 square, 2 square, 3 square and 4 square. Alright, 4 square is 16, which is not less than 10. So this is false. Alright, so your universal quantification is false also. Let's talk about quantifier with restricted domain. You remember, finite means you have upper and lower limit. Let's see what is restricted domain. It is specifying a condition within a larger domain. That means it will specify a upper or lower limit, but not both. When both occurs, this will be a finite, and when only upper or lower will be occurred, then it will be restricted domain. Alright, let's do example. Existential z greater than 0, where z square equals to 2 is your statement. So your restriction should be z greater than 0. Alright, where for this you find out z square equals to 2. So there exists at least one value for which z square will be 2. Think about this. For which value z square will be 2? 1 square is not 2, 2 square not 2. So it will be root 2. That means we find at least one value. So our existential quantification is true. Alright. Hope you understand, and we'll meet in the next video. Till then, goodbye.